At a security checkpoint, every person who enters is scanned, identified, and assigned a category, like this visitor badge. A lexical analyzer performs this same task for a compiler. It takes human-readable source code and translates it into a rigid stream of tokens. This translation happens across 6 components. The input buffer stores the code, the scanner reads it, the pattern matcher identifies it, and the token generator formats the output, all while the symbol table and error handler manage the data and exceptions. This system functions as a high-speed assembly line, stripping away raw formatting and categorizing every character into the machine-parsable grammar required for the parser. The pattern matcher relies on a character-by-character decision tree. For every input, it executes a logical check to determine if the character is a letter, a digit, or an operator. When the scanner reads the S, U, and M in sum, it moves down the letter branch. Once it hits a space, the delimiter tells the system the word is complete, and it generates the identifier token. If the identifier is new, it is logged in the symbol table. This provides a permanent reference point that the compiler will use in later phases to track variable names. Delimiters like spaces or punctuation are the essential triggers in this process. They provide the signal that a pattern is finished and ready for categorization. This creates a problem when the scanner reads a word like if. Because if is made of letters, the basic decision tree would categorize it as a general identifier rather than a reserved language rule. To resolve this, the system performs a secondary lookup. The suspected identifier is checked against a keyword table. If a match is found, the system reclassifies it as a keyword token. A word like while count goes through the same check. Since it isn't in the keyword table, it retains its status as a standard identifier.
Let's apply these rules to a specific string, while, parenthesis, I, less than 5. The keyword table identifies while, the operator nodes handle the symbols, and the digit branch processes 5. The resulting stream is ready for the next stage of compilation. These secondary data structures are necessary to resolve the structural ambiguities that a simple character scanner cannot identify on its own. If the scanner encounters an illegal character, like the @ symbol, or an unterminated string, the error handler halts the process and identifies the specific lexical error. In a live system, these 6 components move simultaneously. Raw characters enter the buffer, route through the decision tree, check the tables for ambiguity, and emerge as a token stream for the parser. The workflow follows 4 operational rules. The scanner reads, the tree categorizes, the tables resolve ambiguity, and the generator formats the token. Understanding this internal pipeline prepares us to explore the formal logic behind it, regular expressions, and finite automata.